Best leg and greetings to all my dear students. Well, today I'll be starting with the last and the final chapter of the first unit of your curriculum, and that is the programming and computational thinking. As a matter of clarification, there are three important units. The whole Class 12 Computer Science syllabus is broken down into three important units. The first one is Programming and Computational Thinking, for which I'll be covering the final chapter, namely the working with functions, and then which carries the largest amount of the marks, and that is 40 marks out of 70. And then you have the second unit of database, which is extremely important, and that carries 20 marks out of 70. And then finally you have the theoretical chapter of computer networks, which is worth 10 marks. So these are the three important units. So I'll be finishing up the first unit with the end of this particular chapter of working with functions. This chapter of working with functions comes first in your textbook. If you leave aside the first two chapters of the review of the Python programming language, which are basically the reviews of what you have learned in class 11. So if you leave those two chapters aside, this function is the first, this chapter is the first chapter of your textbook. So you may be wondering a little bit why first chapter is being taught the last. Initially I thought I won't get much time to make video lessons on computer science subject, but then that's the reason why I started with the more important chapters, or the later chapters, which are bigger in size. Now that we seem to have some more time before the school reopening, I thought, why not finish the last chapter as well, which is working with functions. So this is just a little clarification, because some of you may be a little surprised why first chapter is being taught at the last. So you should feel a little easier to understand now that we have used functions in most of the other chapters with a little understanding. So I could say that you have fair amount of idea over the function as a chapter, or function as one of the important features of a programming language. But from examination point of view, this particular chapter carries quite a bit of marks. So it's so important that we know in and out with regard to the chapter of working with function. So without any further ado, let's get started. So these are the points or the topics that I'm going to touch upon. So let's get started. So what is meant by function to begin with? Function is nothing but a named unit of group of statements. So it's often not a good idea to write one large program without the use of functions. So it's much a better idea to have that one big program broken down into logically independent units in the form of functions. So function is a named unit of group of statements which are meant to cater to a specific kind of a function. In the last chapter of the Python libraries, we learned quite a bit about the built-in function like the for function, the Sqrt, right? So when you look at those functions, you could immediately figure out that it's logically independent in nature, and then the very function is very much specific in nature, okay? Sqrt, it's just to do with the square root. For function is to raise a base to an exponent, right? So likewise, in this particular chapter, we are going to learn how to create our own function. And then there are many other important terminologies with regard to the function. So Let's take a mathematic example. I'm sure you must be very familiar with such a representation of polynomial. So this is an example of a polynomial, and fx is the representation of this particular polynomial. So I don't need to explain much. You have learned it already in your junior classes. So when this function receives a value of 1 for the x, the answer or the solution should be, if the value of x is 1, 2 times 1 is 2, and then 2 plus 1 is 3, right? Now let's say if I just change it to 3, so the answer will be 5, right? So likewise, if f of 2, if this is the situation, then the answer should be 7, right? So these are the mathematical function. So we call it mathematical function, or we use our function in programming. Basically or logically, they mean the same thing. So this is like the real, the functioning part of the fx, right? And this is the representation or the name of the function. And this is the argument in which the value is being received, right? So this is nothing but the example of mathematical function. Now let's move on to, if I want to implement the same thing using the function in the program, it should be like this. Now let's say, okay, I'll just change this to hash. Let's change this to the comment. Okay, now let's write a function in a program which will do the exact same thing. You need to always start with the def keyword, right? I'm sure you must be familiar with this. Def starts the definition of a function, and the name of the function is f, something which is very much similar to the mathematical function, right? Name of the function, and then x is the argument or the parameter, right? And then in this, the actual functioning of this function is 2x plus 3. So I'll have the return statement, and then let's have the very arithmetic expression 2 multiplied by x plus 3, right? Okay, so I'm just trying to make you have a good comparison, feel a good comparison with the function in programming and the function in mathematics, right? So how do you call this function, right? So I just have f, or I need to print this, right? Print f of 1, right? Okay, so I'll just save this, and then if I run it, you know, I'll get the answer as 5, right? So f of 1 gives us the answer as 5. And then in mathematical term also f of 1 is equal to 5. So we call it mathematical function or function in programming. Basically it's the same thing. So this is the name of the function, and this is the body of the function. This is the name of the function. This is the body of the function, alright? And then this is the function call, alright? So don't be confused with this. This is the body of the function, and then this is the argument which receives the values of 1 and 2. Likewise, this is the argument which receives the value from the main part of the program. It could be 1 or it could be 2, right? So this is the brief introduction on how to write the function. Now let's move on to the next. Now let's come up with our own function, right? And then we'll try to understand some of the important terminologies like arguments, the function call, the function definition, right? So let us first come up with a function which will receive 2 integers, and then it will return the sum. We'll keep the program as simple as possible. So write a function that accepts 2 integers, and then it will return the sum of 2 numbers, right? So you have the def keyword, the name of the function, let's say will be calc sum, right? Okay, and then I'll have A, and then I'll have B, right? And then return A, or C is equal to A plus B, and then return C, right? Now let's write the main part of the program, say x is equal to int input, input, and then enter first number, right? Okay, and then we'll do the same thing for y is equal to, this should be equal to, right? Y is equal to int input, enter second number. Okay, there you go. Now let's make the function call. Let's make the function call, and then we'll just have the print sum is equal to, and then you have the function call like calc sum, and then send two parameters of x and y, right? That should do. Okay, so you should feel very confident with this particular example, right? So we'll just run this and check. Enter first number, say 10, and then 20, I'll get the answer as 30, right? So this is one example of the user-defined function. Functions which are defined or created by us. So you got to understand this. So this as a whole is called function definition, right? This as a whole is called function definition. The function definition has the function header. Def keyword will start the function definition. That's very important. Def is a keyword which starts the function definition, and the first line of the function definition is called function header. The function header is very important for the Python interpreter. Okay, Python interpreter, when it starts the execution of the program, it will check the function header to test whether the function header is following the rules or the syntax or the grammatical structure. So this is called the function header. And then you have A and B as parameters. Okay, A and B are parameters, and then this is called the body of the function, right? So it's time to get absolutely clear regarding all the aspects of functions. So def keyword starts the function, calc sum is the name of the function, A and B are the parameters, the first line is called the function header, and then these two statements are the body of the function, alright? And then, now this particular statements, if you take a closer look, they don't have the indentation, alright? You don't have the indentation. So generally what happens is the function definitions are written at the top. The function definitions are written at the top, followed by statements which have no indentation. So these statements are called top level statements. So you have three statements: statement number 1, statement number 2, statement number 3, which are called the top level statements. These top level statements are considered as the main part of the program. They are considered as the main part of the program. This main part of the program, it's a name or it's a value which is stored in a variable called a name. Let's just check out this. Say print, and then 2 underscore, I guess, 2 underscore. And then I write name here. This is nothing but a constant. So when I run this, we just try to check, say 12 and then 13, right? You get the answer of 25, but this is a constant. It's a variable. When I print the value of this variable, I get to see this, right? So what do I mean is, this part of the program is called main part of the program. Why main part of the program? Because it is this particular point at which the program execution begins. I repeat, the main part of the program is that part of the program where the actual programming execution begins. Okay, so this is something you should know. So these are statements with no indentation. So the statements with no indentation are referred to as top-level statements, and top-level statements form the main part of the program. If you want to check, you could just print this particular literal variable with which you'll be able to see a main, indicating that this is the main part of the program, right? And then you have this statement as the function call, right? So this is the function definition, okay? How the function will behave, what the function is exactly going to do. So we need to define the characteristics of the behavior in the function definition, right? So this function definition needs to be called, okay? It needs to be called, from the main part of the program, right? So the reason why we have this, the function, the program broken into different functions is, you'll be able to handle the program with much more ease. Okay, if something goes wrong with that particular function, you don't need to worry about the rest of the program. Just focus on that function. Once that's fixed, the whole program will work without any problem, right? If everything is mixed up, if a problem pops up, it's very difficult for you to handle the program when it comes to locating the error or debugging the error. So it's important that you break the whole program into the functions. So coming back to the point, so this is called the function call, right? So when the function is called, you have variables appearing in the function call. Variables which appear in the function call are known as the argument. The variables which appear in the function definition are called parameters. Okay, so x and y which appear in the function call are known as the arguments or parameters. Or you have two alternative names: actual argument, or you can actually call it as actual parameter. So you have three names for this. The one which appear in the function call, you can call it as argument, parameter, actual argument, okay, formal argument. Okay, I hope you got this. Either you can actually call it as argument, all right, or actual argument, or actual parameter. Okay, over here, parameters or actual formal parameters. Okay, formal parameters. So basically, you can use terms like actual, or actual means one which appear in the function call. Formal means which appear in the function definition. Okay, so arguments, and then you have the function. Now we go to the next part. So how will the program execute when you run the? I just ran the program. It came out with the desired output. Now the question is, what exactly is the order of the execution of the program? Okay. So normally, it always starts at the beginning, right? And then it moves on down the line, and then it finishes the program with the execution of the final statement. But over here, there is a little twist. When you have such program, say I have this as statement number 1, 2, 3, 4, 5, 6, 7. Okay? Let's say the statements are numbered as 1, 2, 3, 4, 5, 6, 7. So when you run the function, when you run the program, what happens is the Python interpreter will start at the function header. Okay, it will start at the function header. Okay, so the moment it comes across the def keyword, it knows that it is a function. So the interpreter will just check the header to figure out whether it's a valid function header or not. Now, when I say valid, whether it follows the syntactical rules or the grammatical rules of the Python programming language. And then it skips the body of the function, which means the Python interpreter just takes a look at the first line of the function definition, which is also called as the function header. However, it skips the next two statements or the body of the function. and then it comes here. Okay, it executes this, and then followed by this, and then from here, it jumps to the function definition, the parameters, the arguments of x and y, which is 12 and 13, are passed on to the parameters of a and b respectively, and then the function body will be executed, and the result will replace the function call. You need to get this right. Okay. From here, the control jumps to the function definition. The return keyword will send a value back to the function call, and that returned value will replace the very function call. Okay. And then, since it's used in a statement, that statement will do what is intended, right? It will print, and then finally, you have the statement, right? So we don't have this actually. So if the statements are numbered as 1, 2, 3, 4, 5, 6, the order of execution of the program will be statement number 1, okay, and then statement number 2, statement number 3, statement number 4, okay, but from here it will again go back to statement number 1, statement number 2, statement number 3, and then finally, this statement will again be executed, right? So if you have numbers like this, let's say hash 1, let's say this is hash 2, say this is hash 3, okay, these are the statement numbers, hash 4, hash, what happened? Okay, this is hash 4, and then you have hash 5, and then you have hash 6. Now this is important. Sometimes, the question could be asked like, just list the order of execution of the program. So the answers will be statement number 1 will be the first one to be executed, and then 2 and 3 will be skipped, and then comes 4 followed by 5, and then you have 6. Okay, you have 6, 1, 4, 5, 6. But from 6, when it executes this statement, you have another pending function call, another statement, sub-statement that needs to be executed. So from here, what happens is, it goes back to statement number 1. This needs to be executed again because the value of x and y are passed on to a and b respectively, right? And then statement number 2, okay, and then statement number 3, and then finally, the print statement has to function again. So you will have statement number 6. So this is the order in which a program containing a function will be executed. Alright? And then another important thing to be noted is whenever a function call is made, I think I have written here execution frame, right? So whenever there is a function call, what happens is another part of the program, something like this, will be created. Or technically, if I tell you, it'll be nothing but a memory location. Okay, a memory location will be allocated for the function call. So the moment you have the function call, what happens is execution frame or a memory location will be allotted. So this is meant for the execution of the function definition. So this execution frame will contain information about debugging the program, just in case, if something goes wrong in the function definition, there should be some information or some ways to tackle or report the error. So number 1 is the execution frame will contain some information regarding debugging. Debugging means the process of locating and correcting the error. So it will contain some information with regard to the debugging process, that's one. And then values, it will store values which are sent into the function definition. And then at times, in this particular example, one variable is created, right? So the variables which are created, in the function definition are also stored in that particular frame. Alright? And then more importantly, in this particular execution frame, it will keep track of the statement following the function call. It will store the memory address of this particular statement. Because it needs to remember, once the function definition is taken care of, the execution frame should know, from which part of the program, from which statement, should it continue, right? So it stores the returning point. So that's again important, one important thing to be noted, right? So basically, every time a function is called, execution frame or a part of memory is allotted to function definition, which stores some information. Number one, information with regard to debugging. It's again, number two, to store the values which are being passed on to the function definition, and then to store the variables which are created in the function definition, and then the whole process takes place inside the execution frame, and then it remembers or it keeps track of, or it stores the memory address of that particular line from where the program should continue further, right? So these are some of the important aspects, you should remember with regard to the function creation, all right? Now let's move on to the next. Now there are three kinds of the function. The first one is built-in function. Built-in function means the function which are all the time available to us, right? Let's say if I come up with the example, say 4, 2 of 3, okay, we'll give you the answer as 8. So it's a built-in function which are all the time available to us. And then functions defined in the module, right? Since we are done with the Python libraries, it shouldn't be a problem. Some of the functions need to be imported because they are created in a module. For example, you have Sqrt square root, you cannot use it directly, right? So you have to first import, the math function, and then you have math dot square root of 9, I should get the answer as 3. So this is a built-in function. You have built-in function like type to check the data type, ID to check the memory address. So the functions which are all the time available to us are called built-in function. The functions which are defined in the module, right? That's the second one. For example, Sqrt and all the trigonometric functions like sine, cos, theta, I think they all belong to the functions defined in the module. And the third one is the one which the user creates. Okay, so calc sum is one example of the user defined function. All right. So let's move on to the next. Okay, what do we have here? Okay, now the next topic is the passing the parameters. Okay, till this point, we have been passing the variables from the function call to the function definition based on one single method, and that is based on positional, which means the first argument's value will have to be received by the first parameter in the function definition. The second argument's value will be received by the second parameter in the function definition. So this is what we call as positional. Okay, the first to first, second to second, right? So apart from this, you have two more ways to pass the parameters. The other two are default arguments, and then you have the keyword or named arguments, right? So we'll just check out the first one, right? Now first things first, let's come up with the example. The best example could be calculating a simple interest. In order to calculate the simple interest, we need the three important parameters. The first one is principal amount, and then you have the rate at which the interest is calculated, and then for how many years, the time duration you would like to keep the principal amount in your bank, right? So we'll first focus on the positional or required arguments, right? So again, you have the def, the name of the function is interest, right? And then there are three arguments. The first one is print, and then you have the time, and then finally you have the rate, right? You have the colon, and then it's straightforward, right? So the formula to calculate the simple interest is principal multiplied by time multiplied by rate. And then let's work on the main part of the program, okay? So let's call the function, right? Let's call the function print, and then you have interest, okay? Interest, and then I set, let's say 1000, and then you have time for 2 years, and then the rate, okay, is 10% or 0.1, right? So this is the example of the first way of passing the parameter, and that is positional or required argument. Positional means the function call. This is the function call. The function call match. When the function call match the function definition based on the number of arguments, okay, as defined in the function definition. We call it as positional or required arguments. So the function definition is perfectly matching up with function definition based on the number of arguments sent and number of arguments as received by the function definition, right? So the 1000, will be assigned to principal, 2 will be assigned to time, rate will have 0.1. So you have 3 number of arguments here, and then you have 3 parameters up in the function definition. So passing and the receiving are based on positions, right? Hence we actually call it as a positional. Now the required means when you specify the parameters as principal, time, and rate, from the function call you cannot skip, you cannot avoid setting values any for any of these 3 values. You cannot skip or you cannot avoid, you cannot afford to miss. So this is the meaning of required. You are required to send 3 arguments, 3 values, because the reason is up there you have how many required number of parameters? You have 3 required number of parameters, right? So when I say required, you must send. You cannot skip. It's mandatory. It's required, right? So positional means, they are based on position. The passing and the receiving, they should take place on a positional basis, right? So this is the first way of setting the parameters which we have been dealing with till date, right? So if we just run it, okay, right. So 1000, 10% of 1000 is how much? 100 multiplied by 2 is 200. So you get the simple interest of 200. So that's the first way of passing the parameters. Now the second one is default arguments. At times, you can have a common value for a variable. For example, when you want to find the area of a circle, you have constants like the value of pi, the speed of light. In a banking softwares, when the interest has to be calculated for a group of the account holders, they normally have a fixed rate. Okay, so in such situation where the variables will have a fixed value, what is the need to send that common value time and again, right? So why not have the values fixed for these kinds of variables, right? So just like the pi for calculating the area of a circle, for calculating interest, for which the rate is normally fixed. So in these kind of situation, we can have the default arguments, right? In the function definition, we can assign default values to a certain parameters. So now let's say we will have the rate with a default value of 10%, right? So you can perhaps do it like this. Okay, rate is equal to 0.1. Now this time what happens is I'm using, the second way of passing the parameter, that's default arguments. Now this time among these three, so I was a little confused, right? In one of the early explanation, these are called parameters, right? These are called parameters, and these are called arguments. So you can actually, call it as parameters, right? Or formal arguments, okay? Formal arguments or formal parameters. So basically, you have three names for this: parameters, okay? Formal arguments and formal parameters. So formal means something which appears in the function definition. This is argument, right? Or you can call it as actual parameters or actual arguments, right? So if you are getting a little confused, just stick to the parameters and the arguments, right? Now this time I have a default value assigned to rate. So with this, what I could do is I could now afford to skip the argument or the values to be sent to the rate, because you have the rate value with the default value of 10%, right? So it means, so every time I want to calculate the interest rate, I don't need to pass the value for the rate. It's just like, setting the pi value over and over again for calculating the area or the circumference of the circle, right? So if the rate value is fixed, I could have it, assigned to the default values. Thereby, I could avoid setting a value for the rate. So this method of passing the parameters is called default arguments, right? Now say if I change this to, okay, say now if I run this, okay, I get the correct answer as 200. Now this time it is not based on position. Yes, the first two, the parameters, these first two parameters, I could actually call it as the first way of passing the parameters, because they are based on position or required. Position, why position 1000 goes to the first parameter, 2 goes to the second parameter. And then why required, because I cannot skip the values for current and time, they must be sent. However, with this, I'm using the second way of passing the parameter, which is 0.1. But just in case, if you decide to have another rate value, you can pass it from the function call, right? So you can have 0.2, right? So when you save it and then run it, you will get a different output. This time you will get 400, which means the new rate is considered as 20%, not 0.2. So if you decide to send a new rate value, the new rate value will override or replace the default value for the rate. So this is something which is very, very important, right? But you need to keep one thing in your mind. Whenever you decide to assign a default values, there is one important thing to be noted. Non-default values cannot follow default values. Look at this particular situation. Default values is following the non-default values. Okay. However, non-default values cannot follow the default values, which means, I cannot have something like this. Say, okay, I cannot have something like this. Now, this is against the rule. What's happening here is a non-default value is following the default argument. Okay, so non-default argument is following the default argument. This is totally against the rule. Or in other words, all the you can have default values. Now, this is another way of explaining it. You cannot default an argument. You cannot assign a default value for an argument unless and until all the arguments appearing on its right also have the default values. Okay, again, that's another way of stating the rule. You cannot have default values for an argument unless and until all the arguments appearing on the right also have a default values, which means, rate is an argument which does not have a default argument. So this is invalid. So in order to make it valid, you can have a default value for the rate as well. Now this time, look here, you cannot have default values for argument unless and until all the arguments appearing on its right have also default values. So argument appearing on its right is rate. Rate this time also has a default values. Okay, so in a nutshell, if you decide to have a default value for an argument, all the arguments appearing on its right also should have the default values. Otherwise, you are violating the rule. Okay, so this is one important thing to be noted. So all in all, this should be okay, right? But this should not be okay, right? You're violating the rule, right? So the reason is, if the Python allows this, it becomes a huge challenge for the Python program to take care of the entire operation. Okay, so if it becomes very complicated for the Python operation, they make this rule, they come up with the rule, you're not allowed to do this. Okay, so if they come up with the rule, the Python doesn't have to break its head over this, complex issue, right? So this is one important thing to be noted for the default arguments, right? Okay, you now have something like this. Let's say 0.1, right? Now with the help of default arguments, I have certain level of flexibility. In the first way of passing the parameter, there is no flexibility at all. The first needs to go to the first, second needs to go to the second. You cannot skip any arguments, right? But with the default arguments, I can indeed skip a value, right? If I do not, now in this particular example, I can skip the values for time and rate. I can skip it, right? Because they have the default values, right? So the advantage of the default values is we can add additional parameters. We would just go on and on adding the additional parameters, in the function definition, which is something which you cannot do it with the positional or required arguments. Okay, the number of parameters in the function definition must match the number of arguments in the function definition. But one advantage with the default arguments is you can go on adding the parameters, the default parameters in the function definition without having to bother over the function call. Okay, and then another important function is they could combine similar functions. Now with the default values, I could combine seemingly 2-3 different functions. Okay, so when you send such parameters, it looks like I'm dealing with one type of function, right? And then let's say another function call, I skip these two. Seemingly, it feels like you're dealing with another operation, okay? And then I decide to have just the first and the second. Again, it works perfectly all right. It looks like I'm dealing with another function, right? So many number of functions could be combined into one thanks to the default arguments in the function definition. So these are the two important advantages with regard to the default arguments. Okay, I now have this flexibility of skipping the values, but still I cannot mess up the order. Okay, the first 1000 has to go to principal, 2 has to go to the time. Okay, with the default arguments, I cannot still mess up the order. I still need to retain the order, right? So in order to have even more control, apart from the flexibility offered by the default arguments, if you want to have the complete control, where you can mess up the order, that's when the keyboard or named arguments come into the picture. So in the third way of passing the parameter, what happens is in the function call, you can label the arguments. You can have named arguments with the assigned value. Okay, in the function call, you can have the arguments with the name, with the assigned value, with which we could fill, or we could have more control over the order via which the arguments are passed to the function definition. See, I'll show you the example. Now let's say I have something like this, right? Let's go back to the initial. So this is purely based on the positional or required arguments, right? Now let's say I want to have this flexibility of sending the first argument to the third parameter, or the second argument to the first parameter, right? So if you want to do it, you have to name the argument with the assigned values. I repeat, you have to name the argument with the assigned values, right? So let's say I have rate is equal to 0.1, right? Now this time, what am I doing is, the first argument is the rate, right? The first argument is the rate. I have the named argument with the value, right? And then the first parameter, the first argument's value will be assigned to the rate. So this connection or the join is being provided through the name of the required argument, right? And then let's say I have time, say time is equal to 2, and then print is equal to 1000, right? Now let's say I'll just run this and check whether it's working or not. Oops, what happened? I've made a mistake somewhere. Okay, maybe I messed up with the bracket, right? Okay, save it and then run it, right? So I get the correct output. Now this time what happens is, the way the arguments appear is rate first, time, and then principal. But look at the order in which the parameters appear. Print comes first, followed by time, rate. Okay? So through the named argument, okay, or the keyword. Keyword means I'm using these words. These are the keywords, right? So 0.1 will be assigned to rate. Where is this rate? Regardless of wherever it is, 0.1 will be assigned to rate. So the first argument's value will be assigned to the third parameter. Second will be assigned to second. The third argument's value will be assigned to the first parameter, right? So this type of passing the parameters is actually called as keyword or named arguments. I'm using, the keywords or the required parameters from the function definition. So these are the required list, remember? So I'm using the keyword from the required list, okay? So with this, I could have even more control, even more control over the order. At times, if there are just too many parameters, let's say there are 10, and then if you have to retain the order, it'll be a difficult task, right? So if you do not want to bother over the order, in fact, you can do so with the help of keyword or named arguments, right? So I hope you're clear with this. So this is the the end of the first part of the video.